Animal farming contamination of agricultural produce refers to the introduction of harmful pharmaceuticals, fecal matter, pathogens, or pollutants from intensive farming productions, leading to contamination of produce, soil, crops, water, and air, posing a risk to human health and the environment. Various contamination pathways in agriculture include manure used as fertilizer, which may carry bacteria such as Salmonella, E. coli, and Listeria. Water in the form of rainwater or irrigation may be contaminated with pathogens or pollutants from soil or manure, affecting nearby crops and water bodies. Chemicals such as antimicrobials or hormones can lead to residue accumulation in the soil and potentially contaminate crops. Airborne livestock emit airborne organisms via manure, feed, litter, feather, dust, or aerosols, which can settle on crops and soil.
Microbial contamination. Agricultural produce contaminants such as E. coli, Salmonella, Listeria, and Campylobacter are commonly associated with animal farming accompanied by improper hygiene and sanitation. Consumption of such contaminated food products can result in foodborne illnesses, causing gastrointestinal discomfort to severe and potentially life-threatening conditions. Chemical contaminants. Chemical residues in animal products and byproducts come from the use of pesticides, herbicides, antibiotics, and growth hormones used in animal farming. These residues can enter the food chain through contaminated soil, water, or feed, and this is a risk to consumers. Water contamination. Pathogens and pollutants in runoff water from animal farming facilities can contaminate water sources used for irrigation. Cross-contamination. When food produce is processed, transported, or handled in any form, the produce can contact equipment or surfaces that were previously contaminated by animal products or byproducts and potentially introduce pathogens into the food. Allergen cross-contact. Food warehouses or facilities that handle animal and plant-based food pose a risk of allergen cross-contact. Environmental contamination. Farming animals contributes to environmental pollution by the release of waste, antibiotics, hormones, and chemicals into the soil and water sources, potentially contaminating crops. Antibiotic resistance. Antibiotic overuse for animal farming leads to antibiotic-resistant bacteria, which can also be harbored in animal products and environments.
Common foodborne diseases. So firstly, what is a foodborne disease? A foodborne disease is any illness caused by the consumption of food containing harmful substances, microorganisms, or their toxins. Those that are at risk are neonates, elderly, pregnant, and immunocompromised. Common symptoms seen are stomach aches, diarrhea, vomiting, fever, and flu-like symptoms.
Let's discuss the big six of foodborne diseases. First off, we have salmonellosis, which is a cause of about 420 deaths per year in the United States. It causes symptoms like diarrhea, fever, and stomach cramps. This bacteria is ingested when people eat contaminated food or drink contaminated water. They can also get it by touching infected animals or their feces, or even just the animal's environment. Secondly, we have typhoid fever, which is also caused by salmonella, but a different species known as typhi is implicated here. People who commonly get typhoid fever get it from traveling overseas to countries in southern Asia, where it is very prevalent. It differs from salmonellosis because it has a sustained fever that can be as high as 40 degrees Celsius, and it can also include things like headaches, a cough, and a loss of appetite. There is a vaccine that travelers can take, which is definitely recommended if they are traveling to high-risk areas. Thirdly, we have campylobacteriosis, which is transmitted to humans through a variety of routes, those being eating raw chicken, unpasteurized milk, any produce that's been in contact with animals, or untreated water. It causes similar symptoms to salmonella, but it can also cause a bloody diarrhea. Individuals with weak immune systems can get a life-threatening infection if the bacteria enters their blood, and it's known as the Guillain-Barré syndrome. But there is only a 0.1% chance of getting this.
E. coli is a normal commensal bacteria in the gastrointestinal tract of cattle. Shiga toxin-producing E. coli can cause harmful effects to humans, such as diarrhea, stomach cramps, and fever. About 48 million people get sick from E. coli every year, and about 3,000 of them die. Norovirus, commonly known as the infamous stomach bug, which most of us get staying in res. Clinical signs are diarrhea and vomiting. There are over 56,000 hospitalizations a year and 570 to 800 deaths globally. Hepatitis A is the inflammation of the liver. Symptoms include nausea, fatigue, abdominal pain, and loss of appetite. In 2016, 7,134 deaths were recorded globally. Hepatitis A is spread through contaminated food and water and is preventable via vaccine.
South Africa is greatly considered to be a developing country, whereby many communities are affected due to limited healthcare and veterinary services, as well as a lack of knowledge in rural areas. In these specific areas, those affected in the population are usually infants, children, the elderly, and immunocompromised persons. Some clinical signs include diarrhea, fever, stomach cramps, and sometimes even neurological signs. Foodborne diseases result in the cyclic event of sick animals affecting crops, which affects people, which in turn affects crops that distress healthy animals and make them sick. Not only do economic losses arise through animal production losses, but also in the food industry. One of the advantages of urbanized areas is that it decreases the contact people have with animals, which contributes to the decreased percentage of people affected in urban areas versus rural areas. However, this does not indicate that urban communities will never be affected. The process starts with farmers and veterinarians, abattoir workers, and food processors. If one of these areas in the food industry falls short and a disease is missed, great economic losses can be.
Discussing some regulatory measures that can be used to reduce contamination causing foodborne diseases. Vegetables that are sold should be of high quality, kept in the fridge or freezer, and not damaged. Containers used to store vegetables should be washed and disinfected before vegetables are placed inside. These containers should not be placed on the floor. Equipment used to harvest vegetables should be washed and disinfected regularly. Fruit and vegetables should come from reputable sources and be able to be traced back along the production line, from the place of growth to the transport to the processing. Domestic and wild animals, including pests such as rodents, should not be allowed into plantations of fruit or vegetables. Now onto how we can reduce some of the risks of contamination. Containers used to store vegetables should not be used to hold anything else. Equipment used to handle manure on a farm should not be used in reaping the harvest. Workers involved in collecting fruit and vegetables should follow a strict hygiene protocol. Inspections should be carried out on the produce to ensure it is fresh, clean, and free of fecal and soil contamination. Produce should be packed or stored sooner rather than later to reduce environmental contamination. Stagnant water could harbor unwanted pathogens and should be minimized around fruit and vegetable growth.
Let's discuss a case study. E. coli on romaine lettuce. This occurred in Yuma, Arizona in April 2018. There were animal feedlots and grazing areas in close proximity, which posed a contamination risk from animal waste runoff. There was over 200 reported cases of illness, with people experiencing severe stomach cramps, diarrhea, and vomiting. Especially the elderly and young children were at risk. There was tracing of the source and then containing of the outbreak. There was a recall by the FDA and the CDC. This posed the question of the safety of food supply chain. And actions to prevent future outbreaks would be to improve food safety practices, increase traceability in the supply chain, and improve communication between the people involved in growth and the consumption of the food.
In the E. coli outbreak linked to romaine lettuce from Yuma, Arizona, one of the deaths was in New York State. The CDC also says 25 more people became sick 2 to 3 weeks ago from eating the contaminated lettuce. That's when it was still for sale. It's no longer on store shelves or being served in restaurants. In all, 5 people have died and 197 people in 35 states were sickened in this outbreak.
Consumer education and awareness. Promoting safe handling and consumption practices can be done by various methods, including educating farmers on biosecurity, proper animal handling, and hygiene measures. Instructing farmers to implement good hygiene practices such as proper waste management, sanitation, and use of protective gear to prevent contamination. Having workshops or seminars on food safety at schools and institutions to raise awareness. Launching public awareness campaigns to educate consumers on the importance of safe handling and consumption practices to drive the demand for safer agricultural products. And finally, including informative labeling on food packaging that includes safety certifications and potential contaminants or allergens.
As our technologies become more sophisticated, it may become easier to avoid the spread of foodborne disease. Here are some examples of future innovation that could be used. Automated waste disposal and sanitation systems on livestock farms can utilize sensor systems to detect excess waste and robotics and conveyors to clean and dispose of it properly. Automated disinfectant spray systems can also mitigate the need for personnel to manually sanitize the environment. Stricter benchmarking worldwide can be employed by organizations such as the WHO and the WOAH to ensure strict standards for food safety are upheld across the board. Novel animal vaccine innovation, which can be more affordable for farmers and potentially more effective, could help prevent disease spread at the source. And mandatory educational workshops would ensure employees understand hygiene standards that need to be upheld in the industry. Modern food processing technologies such as the use of ozone gas, UV light, high-pressure processing, and cold plasma technologies may be effective ways of inactivating foodborne pathogens without compromising the quality of the food. Utilizing AI for advanced predictive modeling to effectively analyze data sets to predict possible dangers may also be effective. Supply chain tracking can be improved by the use of more advanced technologies like AI to allow traceability in the event of an outbreak to prevent further contamination. Remote monitoring, automated entry systems, biometric identification can all improve biosecurity at a farm level to prevent the introduction of pathogens.
Preventing food poisoning is simple. Play it food safe. Search Healthy WA for tips. Authorised by the State Government, Perth.